Okay, welcome to lecture number 3 on data visualization, and it's a makeup class, like I used to say. For those of you that were not able to attend the previous class, we are going to be looking at data visualization in this lecture. Okay, now first we look at the definition of data visualization. It says that data visualization is a graphical representation of information and data in order to help us understand complex patterns, trends, and insights that we can find in the data sets that we are given. So the main objective is to communicate information effectively so as to aid in making it easier for individuals to grasp a proper understanding and interpretation of the data that we're presented with. Okay, so data visualization can be quite helpful in conveying complex relationships between different variables or to analyze trends of events over time. Okay, so if, for instance, like in our previous class when we talked about gathering data that were as a result of logging, okay, data that has been logged. So if we analyze the data over time, we will find a trend. Perhaps maybe we are monitoring how the machine in an industry is being used, and then every time that we use the machine, we log the information, the present state of the machine. So over time we can be able to analyze the rate, or rather the rate at which the machine depreciates, okay, using the data that we can plot over time. Okay, so next, data visualization can take the form of charts, graphs, maps, histograms, scatter plots, and other visuals. Okay, so we can use color, shapes, and other visual elements in data visualization to make it easy for people to actually comprehend large amounts of data quickly and, most importantly, accurately. So the importance of data visualization, it is for clarity. So visualization aims to present data in a clear and understandable manner. So it simplifies complex data sets and makes it easy for users to be able to identify repeat patterns and relationship between variables, and even to understand the trend of data over time. Okay. Secondly, it helps in generating insight. So effective data generation visualization goes beyond merely displaying information, but it creates an avenue for the data scientists to derive meaningful insights out of data. So by representing the data visually, patterns and relationships will become more apparent the moment you look at the visual information. Now, when it becomes apparent, it aids in communicating, or rather in the communication of the findings. So it becomes a powerful tool and allows data-driven stories to be told, and it aids in conveying information to a broader audience, regardless or irrespective of their level of expertise in data analysis. Okay. Another very important use of data visualization is in quick exploration of a data set. So interactive data visualization enables users to explore data dynamically and thus fosters a more immersive and engaging experience that allows individuals to investigate specific aspects of the data that are relevant to their areas of interest. Okay, it helps in decision support. Data visualization is instrumental in supporting decision-making processes. Okay, it involves and provides decision makers with a visual overview of relevant information, and thus helping them to make informed choices based on the comprehensive understanding of the data sets that they are working with. Okay, there are four presentation types that we have in this domain of visualization. There are the data visualization, there are aspects that you can use for comparison, for composition, and the distribution, and then relationship. We are going to look at different visualization tools that makes for comparison, those that makes for composition, and those that makes for distribution and relationships. How do you know the right charts or the right visualization tool to use? Okay, so to be able to determine which chart is best suited for the presentation type, there are questions that you need to answer. Number one is, how many variables do I want to show in a single chart? How many variables do I want to show in a single chart? Okay, so if it is just two variables, you can just plot this one against the other one. But sometimes there are multi-variable charts. Okay, so the first question to answer is the question of understanding how many variables that you want to plot in a single chart. Number two is how many items or data points you will display for each variable. How many data points do you want to display for each variable? Okay, then number three is, will you display values over a period of time or among items or groups? Will you display it over a period of time? Then you are talking about trend, okay, or among items or groups. Okay, so you must know the following. Bar charts are good for comparison. That's when you are doing a comparison work. And then line charts works better with trends. If you want to plot a trend, what has happened in a business over a certain period of time. Okay, now scatter plots are best used for plotting relationships and distributions. But pie charts should be used only if we have simple compositions. So pie charts is only needed in the area of composition. You will find out that you will not be able to use it to plot a distribution or a comparison visualization. Okay, now the charts in front of us shows us different charts that we can use for different things. Okay, when you look at these charts, we'll have right here the charts that you can use if you are making comparison. Okay, now if you are making comparison, you will have two variables per item, many categories, and then few categories. Now if you are actually plotting few items, you will discover that column chart will be best for this, for plotting few items. And in that area, we are talking about one variable per item. Okay, then, and we are talking about comparison of relationship in a data set. Now, if we are plotting many items, it is better that we use a bar chart. You can quite understand the difference between a column chart and a bar chart this way. Okay, then if you are looking at many categories, okay, you are going to use table or table with embedded charts is described here. You see these tables, and inside of them you have embedded charts. Okay, you also have variable with column charts. Okay, variable with column chart, variable with column chart rather. Okay, that you can use to just plot two variables per item. Okay, now if you are plotting a trend over time, okay, when we are talking about trend over time, you look at that time period that you are checking. Is it a long time period or a short time period? So if it is a short time period, then you can go for a line chart. Oh, okay, or you go for a column chart if you are plotting over a few periods. Now, if you are looking for many periods, you look at non-cyclical data. You can also use when this data is not cyclical, that means it's not like this one, it doesn't go around the time period. Okay, so you use line chart. But if it is talking about if the data you are working with is a cyclical data, then it is better to plot using circular area chart. Okay, now when you come to distribution, what do you want to show in distribution? A single variable, and in that single variable you want to plot a few data points. Then column histogram is there, and then line histogram is there for you to choose. But if you are plotting two variables, it is now better for you to use scatter chart, or what is known as scatter plot. Now, if what you are plotting is three variable, in other words, you have a three-dimensional data, then the 3D area chart will come into play. Now, when you come to composition, you look at whether that composition is static or whether it changes over a period of time. You look at it. So if it is static, then there are three visualization tools that you may choose from. One is the pie chart, then you have the waterfall chart, and then you have the stacked column chart. Okay, then if the data changes over time, the period changes over time, now the next question is the time in question. Is it a few time, or rather is it a short period of time or a long period of time? Now if it's a short period of time, you are going to choose from stacked column chart or stacked 100% column chart, or just stacked column chart. But if what you are plotting involves a long period, then you are going to be looking at stacked area chart. Okay, so then when you are plotting relationship, a two variable relationships or three variable relationship, for two variable relationships you are just going to use a scatter plot or scatter chart, and then for three variables you are going to use a bubble chart. Now when you look at the data set right before you, and you look at whether you are plotting a relationship or whether you are plotting a composition, or how something is distributed, like the marks of students in a course is distributed, or how the ages of students are distributed over a survey, or what you're rather trying to compare one variable with another. Okay, you from this chart will be able to have a quick overview. So this particular slide is going to be a kind of a great tool in your toolbox to aid you with choosing which data at every point you want to use to display your data set, so that you can easily visualize it. Okay, now next we look at those things one after the other. We look at tables versus charts. Now tables are essentially the source of all the charts. Okay, they are best used for comparison, composition, relationship analysis when there are only a few variables. Now you need to note that when you have a few variables, you may not need to go and start plotting your chart, since you can easily look at the table at a glance and discover what it contains, and you can interpret the data right away. Okay, so it would not make much sense to create a chart if the data can be easily interpreted from the table. So tables should be used when you need to compare or look up individual values. Okay, when you require precise value, when values involve multiple units of measures, you're going to need the table. And then when the data has to communicate quantitative information but not trend, then it is better to look up whatever you are looking up using the table. But when you want to use charts, you are already prepared in your heart to convey a message that is contained in the shape of the data. You want to convey a message that when you look at the shape of the data, you will be able to say this one varies over time. Okay, and when you also want to show a relationship between many values, that's when you try to use charts. Okay, but most of the things that we encounter in data science, because we are actually dealing with much data, okay, we usually focus on the use of charts to portray our visualizations. Okay, next we look at column charts. Okay, these charts is best used to compare different values when specific values are important, and it is expected that users will look up and compare individual values between each column. Okay, now with column charts, you could compare values for different categories or compare value changes over a period of time, even though it may be a short period of time, okay, when you want to use column charts. Now, the best practices for using column chart includes, for comparison, if the number of categories is quite small, okay, remember that you can still use what is it called? You can still use line chart to plot trend when the period of time in question is long. Okay, but when the period of time in question is short, you are going to use a column chart. Now, column chart comes in handy if one of your data dimensions is time, including years, quarters, months, weeks, days, or hours. So you should always set the time dimension on the horizontal axis. Okay, in line charts, time should always run from left and never from bottom. Okay, it should always run from your left to your right and not from bottom to top. From top to bottom. For column chart, the numerical axis must start at 0. The numerical axis, if there is need for you to plot numerical values, you must start it from 0 position. Okay, you must start from zeros because our eyes are very sensitive to the height of columns, and we can draw inaccurate conclusion when those bars are truncated. Okay, so you must avoid using pattern lines or fills. All right, so you better use border to highlight a particular column under discussion. Only use column charts to show trends if there are a reasonably low number of data points to plot. Okay, now we look at histogram, and this is just a common variation of column charts that is used in plotting distribution of relationship of a single variable over a set of categories. Okay, there's one variable that you are plotting, but you are plotting it over a set of categories. Okay, now example is the distribution of grades on a school exam, ages of respondents in a survey, and so on and so forth. Okay, now we have the stacked column chart. The stacked column charts are used to show a composition. Okay, they are used to show a compositions like when you look at it at this place. Now, for category A or category B, there are different compositions inside of the stacked column, and this could be different variables that you are looking at. Okay, you are looking at different variables, and then you say for the category A, concerning this variable it is 4.3, concerning this variable it is 2.1.4, and then concerning the other variable it is 2, and so on and so forth. Then the same thing comes in category B, that in category B there are 2.4 2.5 girls, 4.4 male and men, and then 2 children, and so on and so forth. Okay, it can get messy very quickly if you use more than 3 or 4 composition items in a stacked column chart. Next is the bar charts, and bar charts are simply horizontal column charts. That's one of the differences between bar charts and the column charts. Bar charts are simply horizontal column charts. So if you have a long category names, it is best to use bar charts because they give more space for long text. You should also use bar chart instead of column charts when the number of categories is greater than 7 but not more than 15. Okay, for displaying a set with negative numbers. Another example could be sales performance by sales representative. And in this case now, the names can be quite long and there might be more than 7 sales rep that you are looking at their performance individually. Okay, so in a summary, in a bit of a summary, bar charts are simply horizontal column charts that are best suited if the category names in question are long. Okay, now we look at line charts. You use line charts to connect data points showing the trend or pattern of a variable over a continuous interval. Okay, so with line charts, the emphasis is on the continuation or the flow of values. You know, we are talking about the trend. What is the behavior of this variable over maybe weeks, months, years? What is the behavior? What is the behavior of the market price over some certain seasons in the year? Okay, if you want to plot something like that, then the line chart is best suited for that. A line chart is also a good alternative to column chart when the chart is small. Okay, now the most example of a timeline chart might be a stock market price changes over time, which I've mentioned in passing. Then website visitors per day for the period of maybe 30 days, sales number per day for the previous quarter, for instance. Now, when you look at something like this, you can use it to predict a trend. You can use data like this in order to predict a trend when some certain variables are kept constant or are kept under a particular value. Okay, next we look at area charts. Area charts are essentially a line chart that are good for trends and some comparisons. So area charts will fill up the area below the line. So the best use of this type of chart is for presenting a cumulative value that changes over time. Okay, like item stock, number of employees, or savings account, and so on and so forth. Next, we look at scatter plots, which I've said in passing that they are primarily used for correlation and distribution analysis. Okay, they are good for showing the relationship between two different variables where one correlates to another. Then scatter charts or scatter plots can also show the data distribution or clustering trends and help you to spot anomalies or outliers. Like when you look at these charts, you will quickly discover that we have an outlier in this place now. Okay, we have an outlier here. A good example of scatter chart would be a bar chart showing marketing spending versus revenue. And when you look at this place, we look at the product sold versus the revenue generated over the product. Okay, so if we want to plot a relationship between two variables, then the scatter plot is going to be handy and be useful for the case. We look at the heat map in this category. A heat map is a two-dimensional representation of data where values are represented by colors. Typically, a color gradient is used to depict variations in the data. Like you can see here that each column is represented by each cell is represented by a different color. So darker or warmer colors, example red, often indicate higher values. It depends. Each cell in the grid corresponds to a data point, and the color intensity reflects the magnitude of the variable being measured. Okay, now when to use heat map is particularly when we want to show patterns and relationship between variables. Okay, when you are identifying clusters or trends in variables, and then mostly when you are working with multivariate data. Okay, heat maps can display multiple variables simultaneously with different color scales for each of the variables. That is when heat map comes into play. Next, we look at the box plot. The box plot is a graphical tool of the distribution of a data set. It consists of a rectangular box that represents the interquartile range of the data with a line inside of the box indicating the median. Now, when you look at this place, you will see the line inside that indicates the median of the data. Now, another thing that you will find out in the box plot is that it usually has whiskers. Okay, these things that comes up and down out of it, they are called whiskers. So whiskers extend from the box to the minimum and the maximum values within a certain range. Okay, outliers which fall outside this range may be represented as individual points. Now, when you look at this chart example, you discover that we have this, the bottom of this place is showing the median, is showing the least data, and the up is showing the highest data. Okay, now you now find an outlier here that is not within the range of the data. Okay, this is an outlier. Okay, and then you find another category, and then you find another category here. Okay, another plot. Okay, yeah, we have not finished with box plot. Okay, box plot provides a concise summary of the distribution of a data set by highlighting some key statistical measures of central tendencies, such as the mean, the quartile ranges, and the potential outliers. They are useful for comparing the spread and the central tendencies of multiple data sets or groups. Okay, if you are working with a group, you see that in this place you will have category A, you have category 2, and then you have category 3. So box plots are very effective in identifying outliers in a data set, as they visually display values that fall outside the typical range, like we can see in this place. Now, they are robust against skewed data and then can provide insights into the symmetry of the data distribution. Okay, now all of these plots that we have looked at are some of the plots that we'll meet when we begin to handle the practical aspect of it. Now, for our practical classes, we are going to be plotting with matplotlib, and the matplotlib is a popular Python library for creating static, interactive, and animated visualization in a variety of formats. So for us to be able to use matplotlib, first of all, we'll make sure that matplotlib is installed in our Python environment. Now, to ensure that it is installed, we need to use this pip install matplotlib. Okay, or if we are using the conda distribution of Python, we can now use conda install matplotlib. Okay, when you just come to your command prompt, you're just going to type this, and then the library will be installed for you. And the next step is to import it inside of your project. So you import matplotlib.pyplot as plt. The moment you import it, you can now start using the alias name in order to access the library. Now, let's look at an example here. We want to create a basic line plot. So in our data, we say import matplotlib.pyplot as plt. Now, this is our sample data. Our x is a list of items from 1 to 5. And then our y is also a list of items, a list of even numbers, 2, 4, 6, 8, 10. Now, for us to create a line plot of this, we are going to just call the matplotlib.pyplot, which we are calling with the alias name, and then we use this plot function, the plot method, and then we pass the data that we want to plot, the x data and then the y data. Then the next we say plt.show. We use this particular command to display the chart, and what you see here is going to be the output. Okay, so what we have just done here, the output is here. So ordinarily we may not be able to get the relationship between this data and this data easily when they are like this, but the moment you see it this way, you just will discover that this thing flows by half. For instance, that when 1 is 1, the other one is 1 times 2, and so on and so forth. Okay, now if we want to customize the plots, the matplotlib also provides us numerous customization options such that we can be able to add labels, title, legends, change the colors of the plots, and much more. So for us to be able to do that, we are going to look at this. Now first is you are saying plot this data, and you are now saying label. You type what you want in line A, okay, the label of it, and then the color you choose, you call it blue, and the marker you choose to identify those data points. You can use O, you can use X, or whatever marker you want to use to identify. Now we used O here, that's why we have circular points here where those data points are located. Okay, now when we have done that, we now want to plot what is going to be in our x-axis. Look at it, x-axis label, whatever that you want to be in this label, you now add it here, pass it as an argument, as a string inside of this place. And then what you want to be on the y-axis, this is our y-axis, you also pass it as an information. Then what is the plot title? What are you plotting against what? It is very, very needed so that you will be able to know at a glance the data you are passing to the visualization tool that you are displaying. Okay, now if you want the system to show you a legend, you are going to call this legend command. And then if you want it to provide grid, all these lines that you are having here, you are going to set it to true. When you are finished doing that, you will now show that plot by plt.show. Remember that this plt.show is actually an alias name that you can use to call up the matplotlib.pyplots class. Okay, now creating different plot types. When you look at it, we used a plot. When you look at the previous one, we just said plt.plot. Now if you want to identify the type of plot that you want, you are now going to call plt dot. Is it a scatter plot? You call that scatter plot before you now pass the argument, and then every other thing that follows. This one is bar plot, you see plt.bar, and then this one is histogram, you see plt.hist. Okay, now the histogram has arguments that it takes in the data that you want to pass through it, the number of beans, okay, and then the edge color that you want for each of the items to have. Okay, now if you want to create multiple plots, for instance in this one you have subplot, you have subplot 2, and then when you have finished doing that, you can now use the plot.type layout to move the two plots. In other words, you want two plots, you want this and this to be plotted in a single space. Okay, you are going to plot this one differently like we have done before, and then you are going to plot this one differently again, and then you use this method to bring the two together. Okay, that is the end of the class for now. Thank you very much.